Welcome to the Precalc progress check for quarter 2 review. So we're going to start, let me just get the first page here, by finding just the inverses. So for the function, we first have to think, okay, what happened to the x? It became 3 to the x, and then we subtracted 4. So going backwards, the first step is to add 4 to x. And then the next step, the inverse of an exponential is a log. So we'll do log of that prior step. And it has to be a base 3 since that was the exponential. So our answer is f inverse is log base 3 of x plus 4. Okay, so then for 2, we started with x, then we added 5, and then took the ln. So going backwards, the inverse of ln is the exponential of e. So that's e to the x. And then this last step is minus 5. So g inverse, oops, that's negative 1, is e to the x minus 5. All right, for 3, we start with x, then it became log base 3 of x, and then we add 4. So backwards, the first step is to subtract 4, and then change it to an exponential. So that's 3 to the x minus 4. Okay, for number 4, started with x, then we added 1, then took the log of it, and then subtract 3. So going backwards, we're going to add 3, change it to an exponential, and subtract 1. So we start with x, we add 3, change it to an exponential. You have to use the same base, and then subtract 1. So there's my answer. And last but not least, for the inverses, number 5, we start with x, then it became e to the x, and then add 10. So we're going to subtract 10, and then change it to an ln. So subtract 10, change it to ln. And there's the answer to 5. Okay, for 6, use the change of base formula to show that that log is that fraction. So first let me expand my log with the property that if the argument is multiplied, I can separate that with addition. Oh, look, here's that addition. And then the base of 3 is what becomes the denominator. So the change of base formula says we can change this to any base. So this problem's changing it to log base 4 of the argument over the base. So the same logic is because this is multiplied, I can make that log base 4 of 2 plus log base 4 of x. Okay, so let's do the same thing in 7. This problem wants us to change the base 6 to a base 5. So I'm going to start by doing log base 5 of 7x over log base 5 of 6. The argument is in the numerator, the base is in the denominator. The way you can memorize it is the base goes in the bottom. And you just have to use whatever base they're changing to. So then, since the argument in the numerator is multiplied, we can separate the 2 logs with addition and get the answer the problem required. Okay, page 2. one more log problem. This base 8 is now changing to base 2. And then we can change the numerator since the argument is multiplied. Okay, so number 9, we have to use this box of answers at the bottom. So P equals ln of 2 and Q equals ln of 5. So I need to somehow change ln of 10 using the properties to 2 and 5. Well, 10 is 2 times 5, so I can make this ln of 2 plus ln of 5. And then since ln of 2 is P and ln of 5 is Q, P plus Q. Oh, and that's right here. I guess it could be Q plus P too. The order doesn't really matter. Okay, so let's try this one to the right. When the argument is divided, we can separate that with subtraction. So the ln of 2 is P, the ln of 5 is Q, so that has to be this P minus Q here. All right, 25 is 5 squared. And I know that when you have that power, the property says that can become the coefficient. And then ln of 5 is Q, so this is 2Q. Oh, that's down here. We'll do the same thing for 4. That's the ln of 2 squared. So that's 2 ln of 2, which is 2p. And I got that down here. I'm going to rewrite the square root as a fraction exponent, excuse me, an exponent of a half. So that becomes the coefficient. And then the ln of 2 is p. So that's half of p. Oh, there we go. Same logic for this one. That's ln of 5. So ln of 5 is q. It's 1/2 of q. Oh, got that here. And last, division. We can separate with subtraction. So ln of 5 is q. So this is q minus p, which I got down here. I got them all. All right, solving for 10 through 15. Since I have a single log on the left, I can change this to exponential. So that's 3 squared equals 5x minus 11, which is 9. So now I'm going to add 11 to both sides. Divide by 5, and we get 4 is x. But I have to check for extraneous solutions. The argument can never be 0 or negative. So if I substitute 4 back in just to the argument, that's a positive number, so we're okay. 4 is the answer. For number 11, I cannot solve until I make it one logarithm on the left side of the equation. So because of this adding, I'm going to multiply the arguments together. Now I can change it to an exponential. And I'm going to multiply I'll just rewrite it like this. Okay, so now the next step is to multiply the binomials together and do 3 squared. So 3 squared is 9. When I multiply these, we get 25 plus 5x minus 5x minus x squared. So that's 0. I'm going to subtract the 25. Divide by -1. So they both become positive. And when I square root to solve, I need plus or minus of the square root. So the square root of 16 is plus or minus 4. So we really get two answers, 4 and negative 4. So we have to check both. So let me separate them, 4 and negative 4. So if I take 4 and I substitute that in, we get a positive 1 and a positive 9. So that is an answer. Now negative 4, so 5 minus negative, oh, that's okay, that's positive. And 5 minus 4, still positive. So both are the answers. For 12, I'm going to change this to an exponential. And you could use your calculator to get the value of e squared. I'm not going to bother. I'm just going to leave this exact and say e squared minus 4 is x. So to check it, well, e squared, so 2.8 squared is going to be more than 5. So if I substitute 5 minus 4, that's 1. If I put that in for x, we'll get a positive argument, so we don't have to worry that it's extraneous. If you want, you can use your calculator and get the exact value of the decimal and then check your answer. For 13, I'm going to change it to an exponential. And then solve for x. So 50 equals 3x. So 50 thirds. If I substitute that back in, I still get 49 for the argument, so where it's positive, it's okay. 14, I have to condense the logs before I can do anything. Since it's adding, I'm going to multiply the arguments, change it to an exponential. I'm going to simplify the right side. This is x squared minus 4x. Since it's quadratic, I'm going to want my equation equal to 0. Then I'm going to factor. So what multiplies to negative 5 that adds to negative 4 is negative 5 and 1. Set each factor equal to 0. I get x is 5 and x is negative 1. Now I have to check both arguments. If I substitute 5 back into either x, the arguments remain positive. Now if I substitute in negative 1, this x is negative, that's extraneous. It still makes this argument negative, that's still extraneous. Negative 1 is not a solution. All right, and last for 15. Ooh, now we have subtraction between our logs. So I'm going to divide my arguments. I'm going to make this 2 back into an exponent. And now that we have the same logs on both sides, we can drop them. 2 squared is 4. I'm going to make the 4 over 1 so I can cross multiply to finish solving for x. Distribute the 4, so that's 4x minus 4. I'm going to move my x's to the left, add my 4 to the right. So x is 3, but I got to check it. If I put 3 in for any argument, they stay positive, so 3 is my answer. All right, 4 pages to go. Number 16, what is this graph? Well, it starts in the middle and goes to the maximum, so that's going to be sine of x. The period is 2 pi, and the symmetry is with the origin, so that's odd. 17 starts at a maximum, so that's cosine. The period is 2 pi, and the symmetry is with the y-axis. It's the same on each side, so that's even. Ooh, now we've got some as x approaches. So pi over 2 is right here. So as x approaches pi over 2 from the left, this negative means from the left, that's this way, the y value is 0. The little positive means from the right, so as we approach pi over 2 from the right, the y value is still 0. Okay, 18. We have vertical asymptotes at pi over 2. So that makes this the tangent graph. And the period of tangent is pi. Pi over 2. So now we have, oh wait, symmetry, sorry. Symmetrical with the origin again. Like if you totally flip the graph and rotate it 180 degrees, it's still the same picture. So that is odd. So now the pi over 2's. So here's that pi over 2. As we approach from the left, the graph is going up to infinity. And as we approach from the right, that's this way, the graph is going to negative infinity. (19). Let's see, this graph is the cotangent graph with a period of pi. And for symmetry, it's not even, because if I folded it on the y-axis, this part here would be right here, and it's not that. So let's see if it's odd. That graph, does that look the same? And it does, so that's odd. And then pi is now here. So as we approach pi from the left is negative infinity, and from the right is positive infinity. For 20, I'm gonna picture, okay, what function was this built upon? And see how there's cosine in there? So this is the reciprocal of cosine, which is the secant. So the period is 2 pi. It's even, because of the y-axis symmetry here, if I fold the graph, the paper along the y-axis, it's gonna match up. All right, here's pi over 2. So as we approach from the left, it goes up to infinity. And then from the right, we go down to negative infinity. Last graph. And you can see invisible here in the middle is the sine function. So this is cosecant, which is the reciprocal of sine. The period is 2 pi, and it's going to be odd. So where's pi? So here's pi. As we approach from the left, that goes to infinity, and from the right is negative infinity. So if we have the point 5 and root 3, so that's to the right 5 and up root 3. Here's theta. I need to find the radius, so r squared equals 5 squared plus root 3 squared. So r squared is 28, so the radius is the square root of 28. So we have sine, cosine, tangent, cosecant, secant, cotangent. They're all going to be fractions. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And these are the reciprocals, and I wrote them so they lined up. So root 28 over root 3, root 28 over 5, and 5 over root 3. -4 up 3. So r squared is 3 squared plus -4 squared. So the square root of 25 is 5. Because the point is to the left, we have that negative x value. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, but we don't write the negative in the denominator. So I make it negative 3/4. And then all the reciprocals. -5, -12. So r squared equals -5 squared plus -12 squared. And you can use your calculator. So that is 13. So you can use your calculator for Pythagorean theorem if you'd like. All right, 6 ratios again. Oops, sorry. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And because they're both negative, the fraction is positive. And all the reciprocals. One more of these in number 25. To the right 2, down √2. So r squared is 2 squared plus -√2 squared, which is 4 plus 2. So that is the square root of 6. Sine, here's my angle. So sine is opposite over hypotenuse. Because they're both radicals and the 2 and 6 can reduce, you can reduce that to something like this. And the square root of 1 is 1. On the progress check, I'm not sure if it's going to have to be reduced. We will make sure to tell you in class how we're going to want your answer. Cosine is adjacent, positive, over hypotenuse. Because this numerator does not have a square root, we can't do anything to the 2 and the 6. And then tangent is opposite over adjacent. So cosecant, you can either have it as -√6 over √2, or I'm going to reciprocal the final answer. Secant is going to be √6 over 2, and then cotangent's -2 over √2. Ooh, a Ferris wheel in 26. Sarah is riding a Ferris wheel. Carrie starts a stopwatch to collect some data. Okay. I like to use a grid to write the equation because it helps me to have the graph. So at 3 seconds, she's at 80 feet, and it says that's the highest. At 7 seconds, she's the lowest at 20. So that means if this is 4 seconds, I'm going to go 4 more seconds to get back to the top. Or excuse me, Sarah is, because she's writing it. And there's our little graph. Ooh, it's a cosine function I see shifted to the right 3. So the amplitude is going to be the maximum minus the minimum divided by 2. So h of t is 30. I'm going to choose cosine. The b value is 2 pi over the period. So the period is from 11 to 3. So that's 2 pi over 8, which is pi over 4. Oops, t, use their variable. I like cosine because I see that the maximum is shifted to the right 3. And then the midline d is maximum plus minimum divided by 2. It's the middle. I which is 50, so plus 50. And there is the height equation for Sarah. Oops, sorry, I knocked my camera. All right, last question. We made it to the end. A spring-mounted weight is set into motion. It's released from a maximum height of 100 centimeters at 0 seconds. The minimum height is 20 centimeters, and it occurs at 0.7 seconds. So we get back to the maximum, another 0.7 seconds away, so that's 1.4. Okay, so I'm going to choose cosine again because it starts at a maximum, so I won't even have a horizontal shift or a phase shift. Amplitude is maximum minus minimum divided by 2. The period is 1.4, so B is 2 pi over 1.4. That looks funny to me. I don't like a decimal in a fraction. So if I do 2 divided by 1.4, that's 10 pi over 7. That's the same thing. I'm gonna do that. 10 pi over 7. T. You could say plus or minus 0 here. You don't really need that. There's no horizontal shift. But then my midline is 100 plus 20 divided by 2, and that is 60. And there's our equation. This I don't like that plus 0. That looks better. The end. Print another one. Make sure you can do the entire packet with no help before the progress check test. You can do it.